Hi, Rudvi. So I figured this one out, and I don't know how we would have figured this out. It's a trick. We are going to limit compare it to this series 1 over n. How would you know that? I don't know. So just remember to do the limit comparison. All you have to do is compute this limit. And even computing that limit, there's a trick to it because like this is a trig function and this is not a trig function. But we can compute this limit anyways by using good old L'Hopital's rule. Remember L'Hospital? So I know this is a series and not a function, but you can just pretend it's a function. Let's literally pretend it's a function. Right. We're just looking for a limit as n gets big or as x gets big. We can still use all our tricks from calculus of how to do limits. Okay, so remember L'Hopital's. It says you take the derivative of the top and you take the derivative of the bottom. So here we go. The derivative of tangent of 1 over x is secant squared of 1 over x. I'm going to write that as x to the negative 1 times the derivative of 1 over x, which is negative x to the negative 2. And the derivative of the bottom is also negative x to the negative 2. And now you can see these cancel out, right? So the chain rule made that hop out, and that kind of saved us because it canceled it with that. So don't worry about the exponents are negative or whatever. They do just cancel out. So now I'll switch it back to n. Now we're looking for the limit as n goes to infinity of secant squared of x to the negative 1 or n to the negative 1, which was 1 over n. Okay. All right. And as n goes to infinity, so when you're doing this kind of limit, you can kind of just move it to where the n is. So as n gets big, the only thing that's happening is this n is getting big. So this is going to 0, right? 1 over infinity basically is 0. It's not, but you know what I'm saying. So as n gets big, this gets tiny, goes to 0. So that's just secant squared of 0. Okay, and think back to trig. Secant is 1 over cosine. Cosine of 0 is 0. So secant of 0, I'm sorry, cosine of 0 is 1. Cosine of 0 is 1. So secant of 0 is 1. So secant squared of 0 is 1. Okay, so what did we do? We actually computed this limit with a comparable series of 1 over n, which diverges. This exists. This limit exists. So since the thing we limit compared it to diverged, tangent of 1 over n also diverges. Okay, fun. Thank you.